So I have a desiccant, which is a material that you use to remove moisture or water from the environment. So if you think of your silica gel packs that you get in your new shoes or whatever, but I'm using it to pull moisture from some plates that I'll be incubating. What's interesting about this desiccant is that it contains primarily calcium sulfate that acts as the moisture pulling agent, but it also contains cobalt chloride, COCl2, and this cobalt chloride acts as a water indicator if you think of a pH. Taking you back to some early chemistry, so cobalt has a 2+ charge, right? And chloride has a -1 charge. Then they exchange their charges to give you COCl2, right? So the 2 from the cobalt now comes here, and you get cobalt chloride. If you think you have 1 cobalt molecule and then 2 Cl molecule cobalt chloride. Why am I telling you this? I don't know. What does cobalt chloride and equine sports, horse racing, have in common? I was shocked when I found this out. So cobalt chloride in horse racing, what? Now here's the twist. Cobalt chloride isn't just used in labs or as a water indicator. It's also been misused in horse racing as a form of blood doping. I didn't even know that they doped horses. I mean, it makes sense because if track and field or track athletes dope and other athletes dope, not surprised that humans would dope horses. But what happens is that cobalt can trick the body into thinking it's low in oxygen. And low oxygen stimulates or trigger the production of red blood cells, because red blood cells are responsible, for transporting hemoglobin that has oxygen on it in your, from your lungs and back, etc. So when the cobalt chloride tricks the body into thinking it's low on oxygen, the body goes, I need to make more red blood cells because a low oxygen isn't good. And then with more red blood cells being made, it means that more oxygen carrying capacity and more endurance. So the more red blood cells present in the horse's blood, they have more endurance, they can go longer and faster. But this practice is dangerous and unethical. It's been banned in many places, but people cut corners and some places are still doing it. So the same compound that helps to keep my agar plates dry and to keep my plant samples at a constant weight, removing most moisture so I can do dry weights versus wet weights or fresh weights, has a very different story in the world of competitive racing. But let us get back to what I came here to show you. So as I said, the desiccant that I'm using, so if you think of the silica gel packs that are in your shoe boxes or whatever. So this is a desiccant, and it contains calcium sulfate, which is the primary desiccant active, and cobalt chloride. And so if you notice that it is blue in color, right? And in the presence of water or moisture, is that magic? It changes to pink. How cool. So it changes pink to purple in the presence of water and moisture. So my desiccator had the calcium sulfate and the cobalt chloride, and I put my plates in it, covered it, and in 2 days, this was what my blue changed to. What is a desiccator? So it's an airtight laboratory container, and its purpose is to keep chemicals dry, or if I wanted to cool warm or heated materials. So essentially what the desiccator does is that it will protect whatever material I put into it from atmospheric moisture, so from water, etc. And often in the desiccator, you need to use a desiccant, so commonly like silica gel, and you have calcium chloride or calcium sulfate. Anhydrous cobalt chloride, so the dry form, is blue, hence the blue color of my desiccant. And in the presence of water or moisture, the blue color changes to pink purple. Why? Because it's absorbing water, and that is why it's acts as an indicator. So how is cobalt chloride changing color? I'll bring back my paper out. Well, what happens is it rearranges its structure. So first, the purple dihydrate means that it contains 2 water molecules. You have COCl2.2H2O. This is the dihydrate. And then it forms at higher humidity the pink hexahydrate, right? So at high humidity, so moisture, water is in the air, this purplish one becomes the pink hexahydrate. So that means it contains 6 waters, so COCl2.6H2O. And you can also have the reverse happening, where it moves from the pinkish purplish to the blue, forming the solid cobalt crystal. And again, if you were to warm this pink one, the cobalt hexahydrate, gently, say up to about 150 degrees Celsius or so, it will slowly lose water, and then it would form a purple or violet cobalt 2 dihydrate, so Cl2 CH2O. And then this now will go back to the COCl2, which is blue. So it goes purple, pink, violet, purple. But how cool is that? So yes, I wanted to share that with you, and now I'm going to go take care of my microbes. And did you know that silica gel can absorb up to about 40% of its weight in water? Those little bits. And so when you heat the gel, it loses the water and you can reuse them.